Okay, in the past few sessions, we are discussing about the design process, how actually the various steps works in the design process that we are discussing. So today also we are going to discuss the same, right, on the design process, but the next steps. So we know that there are 6 steps in the design process. So out of the 6 steps, we discussed 2 steps. Right, every session we are discussing one particular step, that is how to make this design process successful. So here also, this particular session also, we are going to discuss about the design process, but this design process will say about developing solutions. How to develop a solution, right? We can define a problem, then what we can do, we can justify the problem, and the next thing is, I think we discussed this flowchart, right? We can generate the concepts, and the task step is to develop a solution. So we can define, we know that how to define, and sometimes we can't define problems. Some problems it will be very complicated, and there is no provisions to come, there is no provisions to take, and we could not justify such things, right? So that and all, there is no other way, we need to once again redefine the problem. And the next thing is to generating the concepts. To generate the concepts also, we are taking laws and principles from various subjects, especially we call it as stems, stems. STEM stands for the science, engineering, technology, and some support from mathematics. So such things we discussed in the previous session, right? That is how to generate concepts and what are the important effects while we are generating the concepts. So up to this we've seen, right, in the previous session, you can see the flow chart. It is telling about the first thing, especially the defining a problem, whether the problem is justifiable. If it is justifiable, we can come to the generating concepts. If you are generating concepts, it's okay. The technology it exists. If there is a particular technology exists, we can see that. If the particular technology is not there, then it will go back to the definition of the problem, or it will go back to regenerate the concepts. Right? But there are many scientific results are available. So especially the generating concepts, we've seen the research plays a major role, right? And now we come to the next step called developing a solution. So how to develop a solution, right? What are the main things while we are developing the solution? Because already you defined the problem, you know that it is justifiable, then only you can come to the second step, we can generate concepts. So once we're able to generate concept, the next step we need to do, that is developing a solution, right? So you are having enough concepts because we already did a comprehensive research or comprehensive literature survey, right? From that you can take many inputs for a design. You can imagine any type of the design, designing of mechanical elements, or designing of an electrical motor, or designing electrical generator, or you can say the designing mobile phones, designing a laptop, anything you can take, right? So everything you can, if you are analyzing all these 6 steps will be there, right? Otherwise it won't be successful. You can develop in any manner, zigzag manner, but how much it will be successful is a matter. So first one is we defined, we generate the concepts, and the third one is to develop the solutions. So to develop the solutions, it will say that is create a detailed design solution. So how to create a detailed design solution? So once you generate the concepts, how you can come to the solutions? So listen, you are having some law. Say example, to design an electrical motor, you are having a Faraday's law with you. Okay, according to the Faraday's law, it will say how the motor runs, right? We know how the electromagnetic field creates. So you can get the informations, the detailed informations from the principles of the concepts we generated in the second step. So, second step, you are having some principles, especially from engineering and technology, especially when you are concerned. So you taken some principle, taken some laws. Then what actually happened means you need to develop the solution. So now you are applying. All right. So you studied the theory, and applying is the main important thing. Say if you are going to design a motor, if you are going to a electrical laboratory, you are having all the concepts, whether you can use the concepts given by, anyway, the prime concepts, it will be from the Faraday, but what are all the supporting things, what are all the additional goals that we seen yesterday, so that also need to be satisfied while you are developing a solution. So that you need to understand, right, to develop a solution. So to create a detailed design solution is very important. Means you have to give a report, like while you are designing, this will be the solution. So you can design, for example, you taken this much amount of winding, that is 1 kg winding, you bought it, and your wound, whether it is a lap or wave winding, depends upon the machine you are using, and you were telling about that is how much it will work, that is how much SP will be. So you can justify, right? So what will be the solution, what will be the impact, so what actually after designing, how it will work, right? All those things can be taken care, right, while developing a solution. Right, and when to support the developing the solution, so what are the other things need means we need to draw the technical diagram also. I'm showing one by one, you can see that create a detailed design solution, that is mandatory, we have to do it, and justify the solution path. For justifying the solution path, you need the survey, literature survey that you done previously, right? And to justify the solutions, you need particular principles that already we are having in the theory, right? So while you are having all those concepts, then you can put forward everything in practical aspects, so that you can justify, right? For example, you are studying Kirchhoff's current law, right? And how you can say the Kirchhoff's current law holds good, how you can justify, not simply by mathematics, you can justify by using the practical approach, right? If you are having a breadboard and I am giving some resistance and I am giving some supply, immediately you can justify how Kirchhoff's current law works, how Kirchhoff's voltage law works. Am I right? So like that, if you are buying all the components, whatever you need to develop a particular solution, so what you can do means you can take the path, right? You can sorry, you can justify the solution path from the existing concepts. That is not new, right? And next important thing is to make it, that is to represent it. Right, if you are going to design, the design should have some structure. The design should have some drawing. Nowadays, even civil constructions and all, if somebody is going to make, before that, what they do means they will make a prototype. They will show you a model, right? So prototype, anyway, we will see in the next step, that is mandatory before going to a bigger thing. But before going to the prototype, another thing is the technical drawing. So what actually the technical drawing? Say you are going to solve the Kirchhoff's current law. So what actually you should do means you have to draw a circuit, and in this circuit mathematically you can calculate some value. Then what you can do means the same thing, you connect it in some breadboard, and you can justify whether we are getting the same answer as the mathematics. Therefore, you can justify. Therefore, for that you need some circuits. Right? That particular circuit is very, very important. Right? And if you are going to design a machine, this one I am telling about the circuit Kirchhoff's law. and you want to justify Faraday's law in the machine or in the motor generator, then what actually happen? They should draw a technical diagram. Says this will be this will be, if it is a single phase induction motor, this is the rotor, this is the stator, these are the slots. So this will be the air gap. So some drawing should be there. So depends upon the drawing, they can go for a design. So the technical drawing is very very important. For example, if you are going to design a substation, so substation also you need some technical drawing. So many things we want to discuss in the technical drawing. So in detail we will see in the next slide. Let us see. Yes, the technical drawing. What are the main things there in the technical drawing? Alright, the technical drawing actually provides technical informations. Alright, what are the technical informations? Means it will tell you about, if it is a machine, it will tell you about how many slots there, what actually the HP is, that is what will be the RPM, how much speed it will run, and what will be the type of the machine, that is how much big it is, what is the shape, and it will tell you about another other technical details like how much voltage, how much current it will consume. So these are all the technical ratings that we need before going to do a particular design. Right, it will be common for other things also. If you are taking a civil structure, they will say about what will be the stress, that is how much strain it will be, how much heaviness it will be, and what will be the strength of particular material. So the civil structures they will do like that. And if it is an electronics, they will see about these communication waves, so that is how much it will be, and whether it is cut to the fourth generation or whether it is cut to the fifth generation, that is how it will be. So these particular things will be given in the technical drawing. Right? Therefore, the technical drawing, it will be like a base. Right? It will tell you all the ratings. Right? That is whatever we need for a design. Right? If you want the shape, if you want the material size, then whatever the particular assembly structures and required things. So all those things will be there in the developing solution. Right? So we define the problem, you generate the concepts, so all the concepts you are having, from the concepts you taken you fine tune which one will give the better results. There are many methodologies are there, which one gives the better results, better performance that you taken. That depends on that you are making a solution. Right, and you come to this solution. So this particular thing will work out, and this solution will valid, right? Only if you are having the technical drawing and other supported things, you can analyze and you can come to the conclusion, yes, this will valid, this particular thing will be okay, like that. You can get it. Alright, therefore, three things we've seen till now. That is, one is defined problems, and the second one is generating concepts, and the third one is the developing a solution. And let us see the next one. Anyway, we are going to discuss the next topic in the next hour. Yes, that is the prototype. So once again, you come to the flow chart. The flow chart, it will say clearly, that is, once it is defined, the problem is defined, we can say that the problem is justifiable. Right? If it is justifiable, then it will come to generate concepts. Otherwise, it will go back. And once it is generating the concepts, it will say about whether we need the technology. Yes, if you need the technology exists, right? The technology is there or not to solve. All right, the technology is there to solve. Then it will go to the solutions. Otherwise, it will go back. And now the solution is valid. So now you made all those things and you got the technical drawing, etc. And now you can say whether it will be valid or not. If it is valid, we'll go to the next step, that is construction. All right. So just to imagine, so before going to design, so these many things we need to take care. All right. That means the steps define, generate, and you are coming for the solutions. And the next thing is you can see after getting the solutions, you can make a report for the solutions, and we'll go to the next step, that is prototype. All right. So once we are going to construct a product, listen, till now we didn't make the bigger thing, but yeah, sample. Right. If it is like some other electronic structures, they will make a sample, and if it is a bigger power structures, they will make a small prototype. Right. And the prototype they can make it, and sometimes nowadays they are doing things in simulation tools. In power systems and if you want to modify the network, it is not easy. Directly you are going to the power lines and you can modify, and if you are going to make some trial and error methods, so that is not at all easy. Right. One important thing is, they can make a model like that, and they build the same in the software, and they will check what are the results while we are modifying. So nowadays they're doing like that. They will do everything in the simulations, and finally they will check. Finally, they will come to the conclusion, that is whether how they can go for the modifications, right? Whether the constraints they taken or support, all those things they will check, right? So these are the things from my end about today's session, right? Because every session I don't want to go more than one concept, then it will be difficult for you to learn. So I hope you understood three things. That is, one is to define the problem. The next thing is to generate the concepts, and the third thing is to develop a solution. All right, and the fourth to generate the prototype, and all we will see in the next session. Right. That's all from my end. And if you're having any doubts, you can ask me. Now, in the meantime, I want to ask you some questions. That is very general. I don't think that I will ask you from the physics or mathematics or some formulas like that. I'll ask you some general questions. Are you ready to answer? Can I have some response?
Yes, sir.
Yeah.